Welcome to the 75th video in our series about Unix tools. This is continuing from the 74th video about hard and symbolic links. In the previous video, if you remember, we learned about block devices. Mainframe people call them DASD, Direct Access Storage Device, and they can only read and write blocks. The file system's job is to store files on those blocks. Although Unix sees files as streams of bytes, the hardware can only work in blocks, so it has to have some sort of mapping. And I showed you the B-tree style structure that traditional Unix file systems use. And basically, the thing we wanted to learn from that was every file has an inode, and you have to know the inode number to get the blocks on the disk, because that gets you to the root of the B-tree like structure, which allows accessing all the blocks. So why do we care about this? Normally each file has one directory entry pointing to it, and keep in mind that the graph that stores all the names of files is not the same B-tree structure that you have one for each file. The graph that stores the file names and directory names is a separate graph, still on disk somewhere, but it's part of the overhead. We need those inodes. One thing you can do that we haven't done before is we can create multiple names for the same inode, for the same stream of bytes. If you're on the same file system, you can do that by having another directory entry with the other name and using the same inode number. Okay, so you need to know which block device things are on, and that's on Unix. You can know because each file system is mounted separately, and you can type in the mount command to get a list of those. And if you're on the same file system, which means you're using the same block device, the inodes within the file system are unique. And so you can create a new name to the same inode number, and you do it with this ln command. And Unix will make it easy because you don't have to go look up the number. You can just say ln and then the old name, the existing name that's already in the graph of directory information, and then you give a new name. And when you do that, it enters a new name, but it copies all the information from the old name about the timestamps, permissions, all that gets copied. And then it copies the inode number that old name was using, and it uses that for new name. If you already have a file with the name new name, there'll be a conflict, you'll get an error, but you can use a -f flag to force. And what that does is it removes the old name from the directory, and then it does the link again. So let's look at that in action. Let's say you can see I've got video 74, and I told you could do a ls-li, and you get all the ls-l information, plus you get the inode in the first column. And you can see that video 74 and video 75 have different inodes, so they point to different data. And it's pretty obvious they've got different sizes. But if I wanted to give another name to video 74, I could do it. And so I could say ln video 74.txt, that's the old name, and then my new name is inode video. And when I do an ls-l, I mean they have the same time and the same size, but there's no easy way to tell they're the same file. But if you look at the inode counter, this is the link counter, link counter, that tells you that there are two files, two names for whatever data this points to. And if I do an ls-li, you can see, the inode's the same, and the number is 2. and we have two of these. So inode video text and video 74 text are the same file. And if we stat inode video text and we stat video 74 text, stat gives you the full information, including all the timestamps. You can see they both specify the same inode. It says there are two people pointing to this data, or two names pointing to this data, and the timestamps are identical. Can we change the permissions? That would be one of your questions. Can I make inode video read only? What happens if I do that? Well, if you take a look, you'll see that when you change the permission of inode video, the permission of video 74 also changed. That's because there's only one permission for that data. So if you change the permission on any of the names, the permission changes for all the names to be exactly the same. That's your hard link. And it has to be on the same file system. If you type in mount, this will tell you all the file systems on this computer. And of course, being Ubuntu, they've made it hopelessly complicated and it's hard to see anything. But if we mount and we remove squash fs and ram fs and bin format miss, it didn't work because I used a vim regex, I guess. But we can go old school. If we do it with 2 greps through a pipe. Okay, now we're down to something a little bit better, and you can see ext4. I have home mounted /home. Okay, and then for the root file system, I don't see it. It should be there, but I don't see it. But anything on home, if it path starts with home, you can do the links. Here's another one for boot. So if I wanted to link from home to boot, I can't do it because they're different file systems, and you can't do a hard link to another file system. It's not permitted because boot has inode numbers from 0 to n-1, and so does home. So if you said inode 3, they might both have an inode 3 that's the root of some data, and they're not the same data. And that's why you can't do a hard link across file systems. But don't worry, there's another system you can use. What if you need to have a link, but the link is in another file system? That's exactly the question we want to answer. And it turns out Unix supports that too, and they have something called a symbolic link. A symbolic link doesn't give a new name to an existing inode. Instead, it creates a special different kind of entry in the directory graph that maps one name to another, like an alias. Sort of like, James Bond in some of the older movies. His friend calls him Jimbo. His friend from the CIA, Felix Leiter, he calls him Jimbo. Well, his name is still James Bond, but he's also Jimbo. And so what you do is you create this symbolic link with a -s option. And actually, you can have a chain of these. So Alice could have a symbolic link to someplace else, Bob, which is a symbolic link to this file. And if you open Alice, the kernel will look in the graph and look up Alice, and it'll say, oh, I need to look this up. It'll look that up, and it'll say, oh, I need to look this up. It'll look this up, and it'll say, finally, I've got an inode, and it can get to the data. So let's do a symbolic link. We did some in our video about shared libraries, but let's do another one. We'll use the same file, video74.txt, and we'll give it another name, super boring video. And when we look, it looks completely different. You see it has an L in the first column, normal files have a minus, but an L in the first column tells you it's a symbolic link. And when you come out here, it shows you the name here, and then it tells you, hey, if you open this, go look here. And then when it goes and looks in video 74, that's got a minus. I can get the inode, I can get the data. And you might not believe me. So let's do a head minus N5 of super boring text. Head minus N5 of our hard link. Are we getting the same data? We are. And head minus N5 of the original file. And you see they're all the same thing. They all point to the same data in different ways. Video 74 was the original name. I created another name to the same inode with a hard link called inode video. And then I created an alias or a symbolic link called super boring video that says when you see super boring video, I don't have an inode. I have another name you have to go look up called video 74. And then they go look up video 74 and they'll get the inode and they can get the data. Just like for hard links, soft links have a force option. And if you do an ln-sf, which is what we did in our make file for the shared library, it basically does this, but all in one command. It removes any existing new name, and then it creates the symbolic link. You need to be careful because you can wipe out data that way. So I showed you ls minus li, which gives you everything from ls minus l, but it also shows the inode numbers. The other way I showed you to see the inode number was the stat command. And that's it. You've seen how to create these names. You might still wonder why you need it, and we'll cover that in our next video. But the first video in this group explained block devices and file systems. This video has explained how to create new ways to access the same data with new path names. If it's on the same file system, you can use the hard link. If it's on a different file system, you can use the symbolic link, which is slower because you have to do more lookups. But it works. Thank you for listening.